Yeah, hi everyone. My name is Sarah Fossheim. My pronouns are they, them, and I will be giving you an introduction to accessible data visualizations. Before diving into the data viz aspect of it, I just want to quickly recap what accessibility is for those who are new to it. But I'm going to go through it quite quickly because we have a lot of data viz to cover. So accessibility is the practice of making our websites usable by as many people as possible and giving everyone, regardless of disability or circumstances, equal opportunities and an equally good experience. When we design for accessibility, that means we want to keep visual impairments in mind, so blindness, color blindness, vision loss. That can mean, for example, making design screen reader accessible or providing enough color contrast or large enough text sizes. There's also hearing impairments, which can mean deafness or hard of hearing. So, for example, captions underneath videos. Cognitive impairments, which can mean autism, dyslexia, ADHD, and mobility impairments, which can be neurological conditions or paralysis or loss of limbs. And all of these things can also be situational. So, adding captions on video, we do that for deaf people or people who are hard of hearing, but it's also going to benefit people with a language barrier, people watching a video in a loud environment, if you're on public transport but don't have your headphones with you, or if you have trouble focusing. So accessibility really benefits everyone. And it's important to know that we make products accessible because it's the right thing to do, because we want to be able to give disabled people equal opportunities. But it's also good to keep in mind, especially when communicating with stakeholders, that accessibility first thinking and making our products accessible is going to benefit the entire product for everyone. So in order to make things accessible, we can look at the Web Content Accessibility Guidelines. I'm not going to go through all the success criteria here. If you haven't heard of Web Content Accessibility Guidelines, or WCAG for short yet, I suggest checking it out after this talk. Also, if you're a bit intimidated by it, don't worry. I know lots of people are. In that case, I would guide you first to the Accessibility Project or the Ally Project, which provides a little bit of a higher level, less scary entry point to accessibility. And same with the posters of the UK Home Office. I'm also not going to go through all the elements that you see here, but if you want to read the posters, they have them in both PDF format and text format on their GitHub, which is ukhomeoffice.github.io. But something I think is interesting that they point out is that, for example, for people with dyslexia, you want to use images and diagrams to support text. So that basically says that data visualization in itself is already something we do to make something else more accessible. When we have a large amount of data or when we have a complex piece of information in text format, we can make it more accessible for people by using data visualizations, which also means that it's really important that we make those visualizations in itself also accessible. How we're going to do this, I'm going to come back to very shortly. But before we jump into that, I also want to emphasize that just following the guidelines isn't going to guarantee a good level of accessibility. It's a good starting point, but it's not a good endpoint. The user experience is really important, and especially for data viz. The reason I say this is because of the way data viz works. First of all, we're working with data, which can be really abstract in itself already, can be difficult for people to understand already. Maybe you have a table with 100,000 rows that you want to make easy to communicate. That's a big concept. And on top of that, as it is in the word, it's very visual in its nature. What I mean with that is that we use color contrast, opacity, shapes, icons, text, animations, grouping, patterns, and other visual elements to create context or to add extra meaning to the data. For example, here we see a graph or a map of the United States that shows around 3,000 locations of Walmart stores. And each area has hexagons, and the larger the hexagon is, the more Walmart stores there are in that area. And the color is also going to tell us something. The color scheme goes from red to blue. The more red a hexagon is, the older the stores in that area are, and the more blue it is, the newer the stores are. So by just giving this visualization one look, I can already tell that the East Coast has less Walmart stores than has more Walmart stores than the West Coast, and that the Walmart stores in like central US are much older than those on the East and West Coast. If I had to go through 3,000 rows in a table, that would take me a lot more time to get to that same information. And similarly, there's another example. It's also coming from the D3JS documentation, which visualizes the amount of measles per 100,000 people across the states of the United States and from the 1920s until the 2000s. So it's kind of a matrix with on the y-axis the states and the x-axis we have the years. And the darker the cells of the matrix are, the more measles cases there were. So again, with one glance, I can see that across all states, there were quite a bit of measles cases up until the 1960s. After 1963 to 1965, suddenly there's almost no measles cases anymore. And I can also see that there's a line that says at 1963, now the measles vaccine was introduced. So again, with one glance, I look at the coordinates. So what's on the x-axis, what's on the y-axis, and also what color does it have? And just based on that, I can already tell lots of measles cases up until 1963. Afterwards, vaccine was effective, almost no measles cases. So that's a lot of visual elements, and that's also a lot of visual elements combined that make a really complex concept very easy to understand. But that also brings a lot of accessibility implications. The first one is color blindness. That's the first thing I came in contact with when I started making data viz more accessible. It was a couple of years ago, and there was not that much information out there on the internet yet. And I was working with really big and complex graphs, and it was important that users would not make mistakes. And then I realized, okay, but then we're working a lot with color. I have to do something about this. And I went to the internet, and they were like, make sure you design for people with color blindness. My graphs at the time were using green and red as their most predominant colors. So I ran this through a color blindness simulator. Back in the day, I was using Sketch, which has Stark. These days, I'm using Figma, which has the colorblind plugin, and both of them work the same way. They take your artboard and they generate a couple of more artboards or a couple of pictures where they simulate what your design would look like to people with different color blindness. And when I did that, I indeed realized my design was not very accessible. The green and red for certain types of color blindness would turn out into almost the exact same color, like some orange-green color or either some gray color. So that wasn't very good. So I played around with the different settings, tried a couple of different colors, and then landed on a color scheme that worked quite well. I had yellow and purple. Those worked fine across different types of color blindness. The contrast between the two was also high enough so that even when the entire graph was monotone, I could still see the difference. And I also added patterns just to be sure. But soon after, I also realized that that wasn't enough, because color contrast is another important aspect to keep in mind. I changed my graphs to yellow and purple and made sure they had quite a bit of contrast between each other, but I did not check the color contrast with the background. According to the WCAG, text requires a contrast ratio of at least 4.5 or 3/1 if you're working with large text, and it's similar for visual elements such as bars on a bar chart. As we can see, the yellow against white didn't really work out, not dark enough. And I also found it out when I started using my graph on bad screens in the office and in bad light conditions. It was indeed very hard to spot the yellow. So I had to change it again. And in order to do that, we can use plugins. There's tons of them for Sketch and Figma that do this, and probably also for other design programs. How you do it is you install it, and then you select foreground and background color, and it will tell you whether the contrast ratio is high enough. There's also tools for that on the web. For example, WebAIM has a good one. One that I like using is Colorable. And these days, lots of color palette generators also have a switch where you can say, only show me color palettes where the foreground and background color is at least matches the AA requirements. So is at least 4.5 or 3/1. And those I like using in the explorative phase of the design process when I'm still looking for a color scheme, or when I'm working together with designers or other stakeholders who think that accessibility means boring colors, because it's a really good tool to show here are some colors and color combinations that are really out there, but they still meet this particular requirement. And after you've implemented your code, if you use a tool like X or, for example, Lighthouse in Chrome, those will also give you usually a warning if the foreground and background color contrast is not high enough. Another aspect of color that's maybe a bit harder to measure is the color brightness. If you're a fast reader, you might have seen on my accessibility posters that I showed at the start that it mentioned that for users with autism, that you want to avoid very bright contrasting colors and instead go for more toned down, calmer colors. I'd say that's also true for people with neurological conditions or injuries. For example, myself, I got a concussion a couple of years ago, and since then I am way more sensitive to bright colors than I was before. And this is a graph from CNN that updated live during the US presidential elections. And when I was following along, it actually gave me a migraine because of the bright color. It has a bright white background color, then it has bright red borders around cards, has bright red text, sometimes it has bright blue text. Battleground states have a bright yellow label. Then you have bright blue and bright red bar charts or progress bars. Small dots next to the name of the candidate. Like there's a lot of bright colors going on, and that can be quite painful as well. Moving away from color, the next few properties I'm going to go through a bit quicker, but one of them is patterns. A few slides ago, I showed you the graph that I made where I added patterns on top of bar charts. That can really help for color blindness accessibility, and sometimes you might be working with a pattern that gives extra context to your graph and might be a really good use case for that as well. But at the same time, a lot of patterns, and especially a lot of contrasting patterns, can also make the page way too difficult to look at. So be careful with patterns. Similar animation, especially with data viz related to storytelling, you might have animations or scroll effects that as you explore the data, things move in and out of the screen as helpers to explain it. That can be helpful, but animation generally is also something I would shy away from. It can be difficult for folks with, for example, epilepsy, but it can also be distracting. It can cause issues for people with ADHD, for example. So if you go for animation, first of all, I would advise against it. But if you do it, make sure the user can disable it, either by using the prefers reduced motion media query or with a toggle, or if you want to be safe with both. Symbols is another thing that can be very useful to explain data, because sometimes you might have a little icon next to a label, or maybe the points on your graph, instead of being dots or squares, you want to go for a symbol that more explains what this dot means. That's really great. At the same time, we also have to make sure that we make those things screen reader accessible where necessary, and also that symbols and icons might mean different things in different cultures or to different people. So we also want to make sure we're not just relying on symbols or icons to explain something, and that we also add text. When it comes to text, we want to make sure the language is clear and very understandable. I've noticed myself when doing user tests, even with people who are very experienced within their field, who really understand the data, who know what you're talking about, that still, if the language is too complex, even if they understand it, they find it harder to follow along and to find the information they need. So my advice would be to keep the language as easy as possible. Don't make it easier than necessary. Don't try to make it so vague that it's not understandable anymore. But it's also not necessary to go for really complex language in all of our graphs. And similarly, we want to make sure our graphs are explained properly. An example I really liked was before the presidential elections in the US, 538 ran those predictions. They simulated 40,000 different election outcomes, and based on that predicted who was most likely to win the elections. And they had like this nice article with different graphs around it. And each graph basically had the same format. The title was a summary of what was visible in the graph. This graph predicted that Biden would win the election, so the title of the graph was Biden is favored to win the election. Then we have some text explaining what exactly is visualized there. And then we have statistics. Trump wins in 10% of the cases. Biden wins in 89% of the cases. And also Trump's color is red and Biden's text color is blue. Underneath there, we have dots who display the amount of potential wins for each candidate, which also gives us a visual representation of there's a lot of dots on Biden's side. Biden has a really strong chance of winning. There's barely any dots on Trump's side. Trump is probably not going to win. Besides the text and the colors, they also use the images of each candidate to explain the data. So I don't even need to look at Trump or know that the Republicans use red and the Democrats use blue. I can see their pictures. And on top of that, they also add a legend that still explains the same data again. You might not be able to put all of these different types of data viz into one graph. But for example, when you build a dashboard, you might be able to do something similar, even if it's with dynamic data. The top of your dashboard could, for example, be warnings or important information that you really need to see first. Afterwards, you can have some statistics, and then you can drill down more into the data. And then legends and a bit of a description of how to read the graph is always advised to have on each graph that you have. Someone else that does this really well, I think, is Apple. They also do this really well when it comes to screen reader accessibility. You come to the activity or health app. The first thing they show you is a breakdown of your moving, exercising, and standing activity for that day, and how close you are to completing your goals. So I have set my goals to 350 calories a day, 40 minutes of exercise, and 12 hours of standing. And so I can see here that I have around 50% of my moving goal, around 40% of my exercising goal, and around 50 to 60% of my standing goal. That's with rings that work as a progress bar. And then underneath that, they have the actual numbers, like the actual value of how much calories I've burned, how much exercise I've done today, combined with which goal I've set. And then under that, we can drill down a bit more in the information and see how this works hour by hour. Which hours did I exercise the most? Which hours did I just spend on the couch in meetings? Moving away from the visual aspect, we have keyboard navigation. Keyboard navigation means that whatever you can do with your mouse, you should be able to do with your keyboard. If you have any interaction with a graph, whether that's hovering or clicking on a bar to filter your data more, or some fun scrolling, everything that you can do with the mouse, you should be able to mimic with the keyboard. I think that's an important one because very often when we have very busy graphs, we tend to hide labels and hide them behind the hover effects. But when we use the graphs with the keyboard, we can't necessarily tab. We have to make sure that we actually build it in, that we can tab between the different, for example, bars on the bar chart in that case, and get the information that you would get on hover by just focusing with the keyboard. My advice there would also be, if you can avoid interaction with charts or hovering in order to get special information, I would try to avoid it, because what I've noticed is a bar chart is going to look like a bar chart. A scatter plot is going to look like a scatter plot. It's very difficult for users to know which bar charts are going to be clickable or hoverable and which ones aren't. But sometimes you can't avoid it. And in that case, make sure it's keyboard accessible. That hangs closely together with making things accessible for assistive technology or screen readers. If you have Mac, you will have VoiceOver built in. Same on iPhone. iOS will also have VoiceOver. If you're using Windows, you will have Narrator built in. Those are both free, Common-Era operating system. You can get started with them today to start testing your viz. Other prominent screen readers are NVIDIA and JAWS. You can install those as well, but a good starting point is VoiceOver and Narrator, I'd say. And let's look at another demo related to the US presidential elections. This one is from Fox News. And it's a progress bar that's on top, that was on top of their article about the election outcomes, and would update as the results were coming in. And it's a progress bar where you, on the left, have Joe Biden in blue, and on the right, you have Donald Trump in red. And the progress bar is made out of little rectangles that represent the different states and how many electoral college votes each state can give to that person. So during the election night, you could see the blue and the red filling up and coming closer and closer to 270 that they needed to win. And Fox News was actually one of the only ones that I found that had put code in their website specifically to make sure that the data of that progress bar was communicated. But let's take a look at how they actually solved it.
Joe Biden, image 306. Joe Biden. Kamala Harris. Donald Trump, image 232. Donald Trump. Mike Pence. 1 votes. 1 votes. 20 votes. 4 votes. 2 votes. 11 votes. 10 votes. 10 votes. 16 votes. 6 votes. 14 votes. 4 votes. 5 votes. 29 votes. 4 votes. 7 votes. 20 votes. 3 votes. 13 votes. 12 votes. 10 votes. 11 votes. 9 votes. 55 votes. 7 votes. 3 votes. 16 votes. 3 votes. 29 votes. 6 votes. 9 votes. 3 votes. 3 votes. 5 votes. 6 votes. 38 votes. 11 votes. 3 votes. 9 votes. 18 votes. 7 votes. 3 votes. 15 votes. 2 votes. 3 votes. 10 votes. 6 votes. 8 votes. 8 votes. 11 votes. 6 votes. 6 votes. 4 votes. 1 votes. 1 votes. 1 votes. 81,283,495 votes, 81,283,495 votes, 51.4%. Group. 270 needed to win. 74,223,755 votes, 46.9%.
So that was quite something. Fox News, as I said, they did put the code in there to make sure the data was read, but they forgot to add who those votes belong to. So while visually I can see that there's 1 vote, 7 votes, 10 votes, 12 votes, 20 votes going to Joe Biden, and like 1 vote, 2 votes, 3 votes going to Donald Trump, when I listen to the data, it just mentions all the electoral college votes that could go to either person without context of who they belong to and which state gave them to them. So this actually to me shows that just making this the data available to screen readers is not good enough. We actually have to design a good screen reader experience. And that's going to be case dependent. I cannot tell you in this talk, this is how you make your data with screen reader accessible. This is what you have to do. These are the steps you have to follow, because it's going to be different from graph to graph. I can tell you that if you're working with, for example, D3JS or any other SVG library, you want to add area labels or area labeled by, for example, or use visually hidden text elements or visible text elements in order to make the data accessible. That's from a technical point of view. If you're looking for a library that has accessibility more or less built in, high charts is really good for accessibility. But still, the way you're going to solve it for your specific graph, whether you should hear a description or whether you should be able to navigate through the data, if it should be paginated, if any other context should be given, that's going to depend on your graph, who's going to use it and how they're going to use it. And that's also why, for example, accessibility overlays don't really work. So my advice would be, whether you're working with accessibility, data viz accessibility, or data viz in general, start by looking at the purpose of your visualization. What I mean with this is, for example, the predictions from 538 that I touched upon earlier. People go to the predictions page because they're wondering, Who might win the election? Is it going to be Biden or Trump? Is it very likely that it's going to be Biden? Is it very likely it's going to be Trump? Or is it going to be like a neck-on-neck race? So this graph actually does that, fulfills that purpose quite well. It tells me already in the title what I want to know. Also, from a screen reader point of view, that's also how this is announced. Biden is favored to win the election. Trump wins in 10% of the cases. Biden wins in 89% of the cases. That's what VoiceOver read to me when I tried this. It didn't go into the detail of the specific dots. It didn't care too much about in how many percentage of the cases does Biden win with 200 electoral vote margin, or in how many did he win with a 300 electoral vote margin. I can sort of get that from the graph, but it's not the main purpose. It's not what's visually communicated here as well. Similarly, the Apple Health visualizations that I mentioned earlier, I'm going there to check how close am I to meeting my goals? Have I been standing up enough, or have I just been in Zoom meetings all day? Have I exercised enough? How much have I exercised? Those kind of things, which is also how Apple solves it. When I get to this page, the first thing it reads to me is my goals process. So moving so much percentage, exercising so much, standing that much percentage. And then I can move down and drill more down in the data. And as I drill more down in the data, the screen reader is going to give me more information as well. An example that I also like is coronavirus. There's lots of graphs out there for the coronavirus. Most of them are not accessible. But for example, this one from Google, accessibility aside, when I go to Google, or when I go to my local government's website to look at a histogram or a line chart or a bar chart or whatever about the coronavirus cases, I go there because I want to know, how severe is the coronavirus in my area right now? Is it going upwards, which means that probably more restrictions are going to come, or is it going to go downwards, meaning that probably the country will start reopening? So that's, for me, what's the most important information here. So if I were to use this with a screen reader, maybe the individual points from March 2020 to March 2021 is not something that the first thing that I want to know there. When I look at this graph, or when I listen to this graph, what I want to know is, what is it like today? What are the general trends? And then I want to move and drill down into the data. If you were to show this to a researcher researching the coronavirus, researching how it spreads, or how it progresses throughout the year, those kind of people will probably want a lot more information and want a different type of summary, and also want a different type of detail and different level of drilling down. One that illustrates this quite well as well is the job loss during Corona. This is a graph published by the New York Times at the start of the pandemic. What it shows is from the 2000s until March 2020, what the average weekly job loss in the US was. And we can see that throughout 2000 to 2020, or February 2020, that weekly average is around 345,000. And there's some spikes during the 2008 recession, but not very high spikes. And then in 2020, in one of the weeks in March, that week, the claims were 3,283,000. I think this is also a good example of where visually we get what we want to know. We are made to think, oh, wow, so many people lost their jobs, and this is how this compares to the big recession in 2008. I don't care when looking at this what the exact number in August 2014 was. And in my opinion, if we were to make the screen reader accessible, this is one where just the description would probably be good enough, compared to going through 52 weeks of data per year. So around, 20 years, 20 times 52, around 100 whatever weeks, 1,000 weeks of data. That's a lot. And again, in some situations, maybe your user is interested in it, maybe your user is not. That's something you will have to figure out. Last example is, again, the measles vaccine. When publishing something like this in a magazine for people to see how great of an impact vaccines have, then the only information you want to know is how drastically did it go down after the measles were introduced, getting something powerful. So many people each year or each month got the measles up until the vaccine was introduced, and then almost no one got it. While if I would be a researcher looking into the effectiveness of vaccines or the spread of the measles, maybe I would also be interested in a summary per row. For example, why did the measles not have a huge outbreak in Alaska until the mid 1950s? While, for example, in South Carolina, they had a huge outbreak in the 1920s already that remained. Maybe that's the level that I want. Or maybe I want to go even deeper and explore per year. So that's also something where even the same graph shown to different people might require different accessibility measures. So data, its intended use, who it's going to be used with, it affects the way we design our graphs, and it's also going to affect how we make them accessible, whether we're talking about screen reader accessibility, keyboard navigation, or color, description, symbols. A lot is dependent on the user, which is again coming back to the first point I made, that the user experience is a really important part of data viz and of accessibility. And in order to achieve that, accessibility should be part of our entire process. That means that different people are going to be involved there. When it comes to the visual design and the implementation of that, you will have designers, UXers, maybe brand people, developers involved there. There, your focus will want to be making sure there's enough contrast, making sure things are screen reader accessible, making sure all the different WCAG requirements are met. There's a lot of them. But then you also have a lot of other disciplines, for example, QA testing. Often we tend to forget to test for accessibility. We have to remember that when we test for all the other acceptance criteria before releasing a product, accessibility is part of that. Similarly, copywriting and internationalization, we talked about how clear language is important. That goes under copywriting, but also making sure that the language remains clear, that you're not using weird figures of speech, that those are not translated in an awkward way, that symbols are recognizable across different languages and cultures. That's something to think of as well. Data scientists can be useful. In the past, I have used the people who produced my data to actually sit with and really understand what's important about this data. Okay, this part is important, then we have to go for this and this and this solution in the UX. So they can be good as collaborative partners to understand how to make something accessible, but they can also be used, for example, maybe you want to develop some really fancy machine learning AI that detects patterns in a data set and helps you communicate those. If you want to bring all those disciplines together, you're going to need good project managers, and project managers will have to be aware of accessibility as well, because you want to make sure everyone that's going to develop or design or work on anything, that they have time and that they have the resources they need to make it accessible and to test for it. And finally, I'm also putting investors and leadership on this list. In the past, I've noticed that what makes accessibility hard, it's not always accessibility in itself. It's not necessarily the technical aspect. It's actually getting to work on it. Having someone there who lets me work on it. Often, I've noticed that people are just, sorry, this is going to be too expensive. We don't want you to do this. On the other hand, the times that accessibility has been done really well, it was also because the company had a culture that fostered accessibility. People that were really mindful of it, that wanted to prioritize it. And if you feel overwhelmed by all of this, that's fine. Remember, it's okay to start small, but you need to have a plan for the future. For example, you don't want to have, in most of the cases, you don't want to have a table as an alternative to a graph for screen readers. We make a graph to make data in a table more accessible. So then we cannot, to blind people, just give them the table again, because that was what was inaccessible in the first place. However, sometimes you might come across a really difficult graph, might not know where to start making it screen reader accessible. if you don't know where to start, especially when there's lots of interaction and lots of concepts to communicate, you might make it worse by trying to make it accessible if you don't really know what the right thing to do is. So in that case, maybe you could start with just an accessible data table. But then you have to take that table to your blind users or to other people using screen readers. Test it, check how they interact with the data. Maybe have a conversation with them. Maybe you can explain what's visually on the graph and do user tests that way to gain insights and then bring some of those insights back, gradually make your graph more and more accessible. Maybe after the table, you add a description. Maybe then there's some interaction. Maybe then there's some extra statistics. You can do it iteratively as long as accessibility was part of it from the start. And in all of that, it's really important to include disabled people in your process. Take your designs, take your products, take them to disabled people. And if you can't, ideally you would be able to do it, but if you can't, I would suggest maybe invite someone to speak, a disabled person, or watch videos or read blog posts by them, understand their needs, and make sure that whatever you create, it's driven by the needs of the disabled people. And remember in all of that accessible products are better products. As I said in the start, we want to make our Viz accessible because it's the right thing to do. But what I've noticed with DataViz is, especially with DataViz, is that by thinking accessibility first, we actually can discover a lot of user experience problems as well. Often when I come across a graph that I find really difficult to make screen reader accessible, for example, because of the amount of color and information and patterns that are explained, that's usually when I take a step back and think, am I solving this the right way? Was this the correct design? Or should I just redesign my graph? And usually I've noticed when I design it with the idea in mind that this should be easy to communicate with a screen reader, that's usually when I make graphs that are very easy to understand for everyone. And I wish I could keep talking about this. I have so much more to say, but we are soon running out of time and I'd like to have time for questions. So I'm going to redirect you to our GitHub profile. It's github.com/dataviz accessibility or github.com/dataviz ally, depending on how you want to pronounce it, where there's a ton of resources on how to get started with DataViz accessibility. And you can also reach out to me on Twitter or through my website. I'm Liat Risbian on Twitter, and my website is fossheim.io. So please let me know if there's any questions after the presentation as well. I'll gladly help out.
Awesome. Fantastic presentation, Sarah. Everyone has loved it so far. So yeah, I want to dive into some questions because we do have quite a few here. So the first one is, I've designed some charts in the past that have too many variables that would need more than 7 colors or 7+ colors. It can get trickier when the shades are similar. What would you recommend as a workaround aside from adding patterns to it?
My first thing in that case would be try to think if it's possible to split it up in several graphs. That's what I've done in the past. If that's not possible, then maybe patterns could be a solution, but with patterns, you also have to be careful because 7+ patterns, that's a lot of different ones that might also be visually heavy. So my first suggestion there would be take a step back and check, is there a way we can solve this without having to show this many variables and this many colors at the same time?
Great. Another question here. What is a good source to learn about making accessible complex data visualization? Live data, interactive data, comparison of a lot of different data, etc. Where can people go to learn more?
Yeah, so one is the link that I mentioned at the end, which is github.com/dataviz ally. There's lots of them there. I have some blog posts on it as well. Unfortunately, there's not a whole lot of resources out there. I've run into the problem so many times since I started with it. I can find some specific examples, but there it usually stops. It's still a field where there's a lot of work to be done. But I'd say start with the GitHub. That's a good source. And what I've also done is just look at SVG accessibility in general when it's for the web. because a lot of those patterns you can take some inspiration from.
Great, really good answer. Another one here is there a better graph for is there a better graph form that better performs for the accessibility community? For example, a bar chart versus a line graph. What would you recommend?
So specifically, I'm not too sure. I'm not aware of any like big comparisons, but what I've noticed is that when I put my graphs in front of people, usually the easier and the more boring they are, or boring, the less complex they are, the better they perform, both for accessibility and usability. Like the boring thing is a comment I've gotten, and I know other people have gotten the same. Like, oh, we hire you to make this dashboard or to make this nice visualization, and you're coming up with bar charts, or you're coming up with a simple line chart, or it's not that complex. But usually the users who actually use it, they don't want it to be that complex. So I'd say if you can start with something easy and something that's also very recognizable. I personally like bar charts a lot, and I think a lot of people do, because they're so common. Most people know what a bar chart is and how to understand it. But when you have those more experimental graphs, or those that are not as commonly used, unless you're putting it in front of someone who's really into data viz, or who happens to be good at reading data viz, or has seen that type of graph before, it might be a bit hard also to explore. Like, go back to what your users know.
Good recommendation. Okay, so someone's saying in their work, visualizations are used as a path or story for data, and they want their users to get a global overview, then filter and focus to get info they are after, and then only really be inundated with details on demand. How can they achieve the same effect with accessibility in mind?
I'd say the pattern that you describe of getting an overview and then drilling down, just the pattern itself, interaction, let's forget about the interaction, but the pattern of start with something high level and then drill down, I'd say that in itself is a good accessibility pattern. But of course, if you're gonna filter in your graph, make sure if you can click, for example, on a bar chart to drill down, that this is that when you use the tab on your keyboard, or when you use the keys on your keyboard, that you can go between the different graphs, that you don't need a mouse to click, that it's very clear where you can click, what's clickable, what's not. And also, I've seen sometimes when drilling down into graphs, there's lots of animation and stuff popping up. Try to avoid those. Stick to like the general accessibility guidelines, so get familiar with those. Make sure if something is clickable in your graph, it's clickable by keyboard as well. And also make it clear to the user where in the structure they are. Are you very deep down into the graphs and the details, or are you like on a higher level? And when you're in the details, you probably want more details to be communicated to the screen reader as well. Like if you come to the graph, maybe you just want to hear a description and say, yes, now I want to navigate, and then you can start clicking. Or you're like, description is enough, I don't need to filter.
Awesome, thank you. Let's see. What recommendations do you have for providing a description for data visualizations for screen reader users when the data you're working with is dynamic? I think this touches on the question that I asked before, but just want to cover it again.
Yeah. Depends about what kind of data and how dynamic. What I've done before is that I've generated some high-level statistics instead of a written description. If you have a big engineering team and a lot of time, I think you could probably generate nice written descriptions as well. But if it's not done properly, it's also going to just cause more confusion. But what I've done in the past, because I was in a situation where the data viz library we were using at the time, it had nothing built in to enable accessibility. There was no way of making the graph in itself accessible. So I had to add some kind of texts until we had time to switch out the graph to something more accessible. And then I generated like you looked at the graph in that case, it was a graph that wanted to show the minimum and maximum values and average values. So with the D3 math functions or the general JavaScript built-in math functions, I generated, this is the minimum of the graph, this is the maximum, this is the average, communicated that, and then linked to an accessible table. And then once we had the time to switch out the graph, I still kept the description, and I actually updated it to show the description visually as well, because we discovered it was helping everyone, not just people with screen readers. And so then I had the description, and then I could navigate through the graph as a second. So dynamic data is a bit more tricky, because when you don't have dynamic data, you can write a beautiful story around the data yourself that makes sense, and you can display it however you wish. If it's dynamic, there's going to be a bit more work to it. And then it's also the question of whether or not it updates in real time, or if it just updates when you load the page. If you update in real time, you will also probably want to look into how to communicate to the screen reader that the data has updated. I think you could use Area Live for that, but if you have a dashboard with 20 graphs that are updating in real time, maybe you also want to go for something different.
Cool, thanks. Another question here, how do you suggest writing alt text for data viz, particularly for the measles examples you gave? Do you communicate the general gist, et cetera, et cetera?
There's a good article out there on writing alt text for data viz. I think it's by Amy Cecil from the Data Viz Society on Nightingale on Medium. I can try to find a link and link it up somewhere. But for example, the measles case, an example there indeed could be that you communicate the general, especially if it's static data, the general trends. On average, there were 30% of the population got measles up until 1963, after which only 5% of the population got the measles. And then maybe you can still offer the drill down afterwards. But that's also going to be, again, start by looking at what am I trying to communicate with the charts? If I put this chart in front of someone, what would they look at, given that it's not a blind person? Like if you would just put it in front of anyone else, what are they looking at? What kind of information are they looking for? And then from there, you can start constructing your alt text.
Cool, thanks, that was super helpful. Maybe you could tweet out the article later today if people want to follow you on Twitter and find that. Okay, so another question here, and I believe your GitHub link that you touched on probably answers this question, but do you know of any recommendations for accessible data visualization libraries that you know of?
HighCharts. HighCharts is the one I know that has the most accommodations for screen reader accessibility.
Okay, great, yeah.
Also, if another alternative would be to create your own using D3. That's the other way that I know that it's possible to make it accessible. A lot of the, especially React-based data viz libraries like React Viz, I think is one that I've used, has nothing. A lot of them, unfortunately, don't. Yeah. But HighCharts is a really good one. Yeah.
Cool, great, thanks. Looks like we have time for one more question with a minute left here. So I think you did touch on this a little bit, but what extra things are needed from accessibility APIs in order to be able to convey information in a visualization? What roles and attributes could we add to ARIA to facilitate this?
That's a good question. I can't on the top of my head think of any specific things, but in general, I think there's a lot to be done in that space. And I know that there's people also working with that. For example, right now, the way of making, let's say, bar charts, the individual bars, to announce them with a screen reader, you would want to add like an area label to each of them, or add them as, what's it called, role image, and then area labeled by with a title and a description. Like we have those kind of things, but it still requires quite a bit of effort from the user, and it kind of often feels a bit like a hack, especially when it comes to navigating through the data with the keyboard and interacting with it, there's a lot there that I think can be improved. Because then you're working with turning SVGs or SVG elements into buttons. So then you have to like start adding all those roles. It would be really nice if we were just given tools that made it a lot easier. And I know that there's people working on that.
Great. So many good questions, and thank you so much for all your great answers. And in general, just your really great presentation. People really, really enjoyed it. So thank you again, Sarah. Great job.
Thank you for having me.
Yeah, people should definitely reach out to you on Twitter if they still have more questions. And I hope everyone has a great rest of their AXCON.
Yeah. Have a nice day, everyone.